Here we're going to be looking at how we can create delegates that exist in C++, delegates or events as they are commonly known in other programming languages, and how we can subscribe to them in Blueprint. We can broadcast to them in Blueprint, and we can subscribe and broadcast in C++. This is a great integration layer between Blueprints and C++. Let's have a look at how they work. The first thing to know about delegates is that they can be dynamic or non-dynamic in Unreal. What does this mean? A dynamic delegate can be serialized. It can be found by its name rather than just having to be compiled against. And crucially, it can be used in Blueprint. So if you need to use a delegate in Blueprint, it needs to be a dynamic one. And it is also less performant as a result of all this serialization being able to be found by name. It's not a direct C++ call. How about multicast? This is another type or variant on delegates, and you can have multicast or single cast, as I like to call them, but that's not really how they're called in the engine. They're just not called multicast delegates. A multicast delegate can have multiple listeners, so that when you broadcast, multiple different classes can be fired off at the same time. And crucially, they have no return value because it wouldn't make any sense. What would you return? A list of all the return values from all of the listeners? It's not very sensible to do that. So instead, what we do is we have no return value from multicast delegates. And then there is a distinction between delegates and events. They actually mean different things in Unreal parlance. And an event is just like a multicast delegate in that it can have multiple listeners. It also has no return value. But crucially, you cannot broadcast to an event from outside the class that defines it. So this is a protection mechanism that makes sure that your events can be exposed as public variables so that you can subscribe to them, but you cannot broadcast to them. But because they are not dynamic, events do not work in Blueprint. So how does this boil down? Well, first of all, you have to kind of ask yourself whether you want to go down the events route or the delegate route. And this is what the declaration macro looks like when you're trying to declare the type of a delegate. First of all, you have these bits in white. They don't change, but everything else here can be omitted or changed out. So for example, if you want it to be dynamic, you put in the underscore dynamic. If you want it to be multicast, you put in underscore multicast. You can have a multicast that is not dynamic. You can have a dynamic that is not multicast. You can also have ones that have return values or don't. Obviously, you can't have a return value if it's a multicast delegate, and then you can have the number of parameters. So in this case, it's one param, you could have two params, etc. So an example of filling this out would be declare multicast delegate underscore two params. Now, don't worry if this doesn't quite make sense just yet. We're going to be trying this out in code in just a second. The other example is the event. So if you decide that you want to go down the event route, then you don't really have many choices here. There's no multicast events because they are multicast. There's no dynamic because that's not supported. And there's no return value. So you just have the option of how many parameters. So it's declare event, for example, 6 params. So let's take a look at how we might expose a function that we currently have in Blueprint from C++ instead. So right now we've got our quest manager, and the quest manager calls this event, call completed quest, and that is an event dispatcher over in Blueprint. We want to create the equivalent of that in C++. So the first thing we have to do is declare a type for the delegate. We want to decide also what kind of delegate we want it to be. Now, in this case, this event is a multicast because we have multiple listeners and we don't need a return type. And it needs to be dynamic because we need to use it in Blueprint. So that pretty much ties our hands into what type of delegate we're going to use. It's going to be a declare dynamic multicast delegate. And then we have to just decide how many parameters we want. You can see the autocomplete is giving us lots of options here. So you can see that what we're passing in here is the index of the quest in question, and there's only one of them, so we make it a 1 param. And then we need to give the arguments to this macro. The first argument is the name of the delegate. This is the name of the type that we are going to create, not the actual delegate, because we then use that type in the actor to create that delegate. Now, the naming convention here is to start with an F, and I'm going to call it F completed quest signature. And then you have to give it the parameter and the parameter name. So in this case, it's an int 32, and the parameter name is going to be quest index. In fact, let's try and match it as much as possible. We've just called it index over here, so let's call it index. So the next stage of declaring this is going to be making a public uProperty. So we're going to make a uProperty that is a new thing here. It's going to be blueprint assignable, because we don't want to overwrite the actual delegate. We want to just assign to the delegate different handlers. So that's what blueprint assignable allows us to do. And we're also going to make it blueprint callable, because that's going to allow us to broadcast to this delegate via blueprint. Then we're going to use the type f completed quest signature, and I'm going to try and match the name that we've got of our event dispatcher, completed quest. So let's build that and see what happens. So apart from a missing semicolon I had, it compiles just fine. Let's go over into the engine, and you'll notice that it has actually renamed completed quest _0 here. And what I want to do is just show you that now that we have this completed quest from C++, we can replace its uses in Blueprint, both in this class, the quest manager, and other classes such as the quest marker and main display that use it. Let me show you how we do that. So let's right click on completed quest _0 and find references to it, and then click on the goggles to look throughout the project. Looks like it hasn't renamed it everywhere. So we might want to search just for the original, which is going to be completed quest, just full stop. And we can see that we've got some bind events to completed quest in main display. So it looks like it might have updated to be pointing to that C++ node already. So what we're just going to have to do is in our quest manager, we're going to call, instead of completed quest 0, we are going to call completed quest. And then we can remove completed quest 0 call, and we can hook up the index into the parameter of that delegate. Now let's have a go at compiling here, and we'll compile over in the quest marker as well, see if it updates things. Seems to have updated correctly, and the main display will just compile that and make sure. And finally, because we don't have that event dispatcher anymore in quest manager, let's go ahead and delete it and go and check that everything is working all right. If we go over to our main map, want to go and play, and if we go through a quest marker, we would expect it to work. So let's go through a quest marker, and sure enough, everything has updated. So we only have to update the original calling site of the quest manager, and we didn't have to update it in the quest marker where we were listening for it, or in the main display where we were also listening, because we chose the same name and gave it the same signature as Blueprint. So that is just a little tip when we're trying to migrate events from Blueprint over into C++ so that we can either call them or listen for them in C++. If you match the signatures, you will have to do a minimal amount of migration. So to recap, we learnt about delegates versus events. We learnt how delegates can be dynamic, they can be multicast, and if they are not multicast, they can have return values, and they can have a number of parameters no matter what they are. We also learnt about the event, and we learnt how the event is essentially multicast, but it is not dynamic, and it gives us some protections, and basically we've learnt about the number of parameters and how we can declare the signatures of events and delegates.